Dear students, welcome to EPG Pathshala. Today in this module, we will be discussing about advanced treatment technology, that is pyrolysis. Population explosion, urbanization and industrialization has resulted in generation of huge amount of waste. In India, around 0.8 kilogram per person is generated every day. Now, what is happening to this waste? This waste is being disposed of into an open area which is not having any protection. This is resulting in a lot of environmental and health hazards. Now, we have to find a solution for this. So, as a result of this, a waste management plan has been formulated. Now, this includes various steps like collection, which includes collection of waste from different areas or different sources like the residential, agricultural, institutional, commercial and so on. The second step would be to bring all this waste into a common place called as a transfer station, where you do segregation either by manually or mechanically, followed by your processing and treatment. Now, there are a lot of treatment methods which are available. Now, the treatment methods can be a biological conversion route or a thermal conversion route. Now, after this processing or treatment, the waste is disposed of into a controlled environment. Now, this controlled environment is also called as a controlled dumping, called as landfills. Many of the developing countries are not following this controlled dumping. They are just dumping or disposing the waste into a common open area without any protection, so that it affects the different environmental matrices such as your soil, water, air, etc. Now, today in this module, we will be discussing about the thermal degradation or destruction route, where the waste will be reduced. Now, pyrolysis is one such advanced thermal treatment technology where the waste will be subjected to heat treatment in the absence of oxygen. The temperature used will range from 300 to 850 degrees Celsius. Now, at the end of this process, the end products which are produced can be used. The end products are of three types: the solid, liquid and gaseous end products. Now, the solid is char, liquid is an oil, and the third one is the gaseous compound, which is combustible. The heat that is generated can also be converted into electricity. So, this is considered as one of the waste to energy, waste to wealth process. Now, with this introduction, now let's get into the learning objectives. The learning objectives of this module include to understand the concept of advanced thermal treatment technology with a special emphasis on pyrolysis. Also, we would be studying about the pyrolysis process and the products generated from them during solid waste thermal degradation. Next, we will understand the mechanism which is involved. Then we will gain knowledge about the types of pyrolysis process and various reactors which are involved in performing the pyrolysis. We will end this module by discussing about the merits and demerits of the pyrolysis process. Now, as I told you earlier, advanced thermal treatment technologies are waste treatment technologies that uses high temperature to destruct or degrade the waste. They are designed to thermally degrade the waste and recover energy in the form of heat or electricity. Its main purpose is to reduce the impact of residual waste on the environment. Now, the pyrolysis and gasification are examples of an advanced treatment technologies. Now, pyrolysis is a thermal degradation method where the waste is destructed or degraded in the absence of oxygen. That is nothing but burning the waste in the absence of oxygen at a very high temperature of 300 or 350 to 850 degrees Celsius. Now, the process description. The pyrolysis is defined as a process in which the organic waste is thermally degraded in the absence of oxygen. Oxygen plays an important role and it differentiates pyrolysis from combustion and gasification. I'm sure you know what is combustion. Combustion is nothing but burning something in the presence of oxygen. And gasification or pyrolysis is degrading or burning the waste in the absence or a limited supply of oxygen. The temperature used is generally between 400 to 800 degrees Celsius, which is comparatively lower than incineration. Now, when compared to other processes, pyrolysis works at low temperature and thereby emits very less air pollutants, unlike incineration. It produces products like char, which is a solid product, oil, which is liquid, and combustible gases. It's a flexible process and it has an ability to produce these three compounds like the solid, liquid and gaseous products at varying levels by altering the operating parameters such as the temperature and heating rate. It also transforms the low energy density waste to a biofuel of high energy density and a high value chemicals. These products that are produced at the end of these pyrolysis process has a wide range of applications in fuel application, as a chemical feedstock and other energy extraction process. Now, the mechanism involved during the process of pyrolysis is the solid waste which consists of many type of complex materials like the paper, plastic, metal, glass, cardboard, biodegradable material, hazardous chemicals and many more. So, during pyrolysis, the large complex polymeric organic molecules which is present in these materials, that is the cellulose, hemicellulose, lignin, they all result in the formation of a short chain molecules. Now, these short chain molecules are further broken down into the solid end product or the liquid or the gaseous products. Now, let's discuss about the various products which are produced in detail. Now, as I told you, pyrolysis produces three different products: char, oil and gaseous product. First, let's discuss about char. Now, char, it is a solid end product and the maximum char is produced when the pyrolysis process is done at low temperature with a very slow heating rate. Pyrolysis of wood at slow heating rate and moderate temperature maximizes the char yield. The percentage of char production depends upon pyrolysis process condition. Moderate heating in the range of 20 to 100 degrees Celsius per minute at a maximum temperature of 600 degrees Celsius results in equal proportion of oil, char and gases. Now, this method is called as the conventional or slow pyrolysis. The char that is produced from slow pyrolysis can be used as charcoal. Also, flash pyrolysis, the char production gets minimized or reduced. Now, few examples of waste pyrolysis can be: pyrolysis of tire results in maximum production of char of around 49.5% with an ash content of about 10%. Likewise, the municipal solid waste yields 35% char and an ash of 37%, which is relatively high. Also, the pyrolysis of wood by batch process results in the char production of 23%. Now, if you look into the calorific value, char possesses a relatively higher calorific value. Around 19 megajoules per kg, 29 megajoules per kg and 33 megajoules per kg calorific value can be derived from char that is produced from municipal solid waste, tire and wood. Char can be used as a medium grade solid fuel. The value of char for fuel production minimizes due to the ash content. That means higher the ash content, lower will be the fuel value. Char that is derived from wood can be suitable for fuel purpose as they contain very less amount of ash, that is 2%. Steam activation, now the char that is produced should be activated. The steam activation can upgrade the pyrolysis char as activated carbon. However, before you do the steam activation, de-ashing is very essential. Now, similar to activated carbon, char is activated also by physical and chemical methods. Chemical activation is done by impregnation of zinc chloride followed by carbonization, and physical activation is done by steam or carbon dioxide gasification. The surface area of tire, which is around 60 meters square per gram, can be increased up to 650 meters square per gram after steam activation. Now this steam activation will open up the pores in the carbon once they react with the steam, and the carbon will be converted into carbon monoxide, carbon dioxide and hydrogen. Likewise, the flax textile waste, char, surface area can be increased from 5 meters square per gram to 900 meters square per gram after activation. The second product, the liquid product that is generated from the pyrolysis process is oil. Now the oil that is generated from pyrolysis process, it contains a very high energy density per unit volume. It can be used as a fuel, and the composition of oil that is produced during the pyrolysis process consists of the organic acids, phenols, alcohols, aldehydes, ketones and furans. The flash pyrolysis process produces the maximum amount of oil of about 70%. The oil generated from pyrolysis cannot be directly used as a fuel and hence require modification. Depending upon the feedstock nature, the pyrolysis can be categorized as true oil, oil, aqueous phase separated oil and aqueous phase oil. Sometimes the oil can be mixed with petroleum refinery stocks and can be upgraded to a premium quality using certain catalysts. The oil generated from this tire, they contain alkanes, alkenes, monoaromatic and polycyclic compounds. Now they generate a waxy liquid. Some feedstocks like plastics, during the process of pyrolysis, they generate a waxy material. Now oil generated from the biomass contains very high extent of oxygen of around 35%. Now this is due to the presence of cellulose, hemicellulose and lignin in the biomass. Even municipal solid waste, which contains paper, cardboard and wood, also generate oil with high oxygen content. Waste degraded in flash pyrolysis might result in an oil of high viscosity, thereby reducing their calorific value. The calorific value of oil generated from municipal solid waste ranges from 25 megajoules per kg to 40 megajoules per kg. The oil generated from the pyrolysis process has a wide range of applications. For example, the oil generated from the municipal solid waste cannot be directly used as a fuel because it contains very small solid char particles. Also, their acidity and viscosity is little higher. The oil can be used as a chemical feedstock. The compounds such as the methylphenol, methoxyphenol furfural, methoxypropenyl phenol that are produced during wood pyrolysis can be used in food, paint and pharmaceutical industry. The oil generated from burning tire contains D-L-limnonene, which can be used as a solvent and adhesive in industries. They can replace chlorofluorocarbon and can be used as a cleaning agent in electronic circuit boards. Benzene, toluene, xylene and styrene are used in chemical and pharmaceutical industry. The waxy oil generated during the plastic pyrolysis can be used as a catalyst to crack and produce gasoline. The third compound that is produced during the pyrolysis process is the gases. Now the gases generated during the pyrolysis process consists of hydrogen, carbon monoxide, carbon dioxide, methane and other hydrocarbons. Now high level of carbon dioxide and carbon monoxide are derived when the waste material contains cellulose, hemicellulose and lignin, that is your biodegradable material. High levels of hydrogen and methane and other hydrocarbons are formed during the pyrolysis of tire and mixed plastics. The gases that are produced at the end of pyrolysis have medium to high calorific value. Now the conventional pyrolysis of municipal solid waste, they produce a gas of calorific value ranging from 18 megajoules per meter cube when compared to wood that produces 16 megajoules per meter cube. Now, high heating rate and temperature breaks down the products or the pyrolysis oil into gas. So, the maximum calorific value is found during tire pyrolysis, which results in a calorific value of 40 megajoules per meter cube. Also, the higher gas yields are generally produced when they are kept in a hot zone for a long period of time. Generally, the gas yields are very higher at a temperature above 750 degrees Celsius, and the gas generation will be around 70% at this temperature. Now, let's discuss about the different types of pyrolysis units or reactors which are used for the pyrolysis process. One is your slow pyrolysis, then comes your flash or fast pyrolysis, then vacuum pyrolysis. Now, slow pyrolysis, it's also referred to as a conventional pyrolysis, and in this type the heating is done at a very slow pace at low temperature. Now, this results in the maximum production of char. Now, how it is performed is like the heating is done at a temperature of 600 degrees Celsius at a heating rate of 20 degrees Celsius to 100 degrees Celsius per minute. The oil, char and gas production becomes equal at this condition. Since the process involves slow heating rate and slow removal of products from the pyrolysis unit, the formation of secondary reactions are very frequent. Now, the fast or flash pyrolysis involves a temperature below 650 degrees Celsius and a very high heating rate of 100 degrees Celsius to 1000 degrees Celsius per second. This process will result in a liquid of 70% with a minimum amount of char and gas. The gas production is minimized due to rapid quenching of the liquid generated during the process. Likewise, high reaction rate also minimizes the char formation. Generally, wood and tire are pyrolyzed using the flash pyrolysis process. The vacuum pyrolysis is carried at a very low pressure of about 5 kilopascals. It involves a very short residence time and a low decomposition temperature that reduces the occurrence and frequency of secondary reactions. Vacuum pyrolysis can be used for different types of waste, starting from your household waste, wood, plastic, tire, and even circuit boards can be pyrolyzed. This type of pyrolysis is not popular among other types. Now, we'll discuss about the pyrolysis reactors. Fixed bed reactors are simple reactors which are commonly used in laboratories for the pyrolysis process. They are simply designed and they are easy to be constructed. The reactor is generally made up of a stainless steel which is heated externally through an electric furnace. Before the process, the unit has to be flushed with nitrogen or argon to maintain an inert condition or oxygen-free condition, because pyrolysis is done in the absence of oxygen. Now, the waste will be placed inside the reactor at the bottom, and generally the fixed bed reactor will work in the principle of slow pyrolysis, where the heating rate will be very low. The drawback of this particular process is, one, lack of uniform heating due to non-movement of waste within the reactor, and fixed bed reactors can be used for large scale applications only if the heat transfer and distribution is uniform. The gases generated during the process are removed every day while the char is collected at the end of the process. The second type of reactor is a batch reactor. Now, this reactor, the waste is loaded, sealed and then operated. No addition of reactants or products is done during the operation. A high conversion rate is generally observed in this type of closed reactors. Even semi-batch reactors can be used where addition of reactants and removal of products can be allowed. At the end of pyrolysis, the product is not uniform for every batch process. This might be the major disadvantage of semi-batch reactors. The third type of reactor is a fluidized bed reactor, where the waste material is generally fluidized within the pyrolysis unit. Fluidization generally results in mixing and good distribution of heat throughout the waste. The characteristic feature of fluidized bed is high heating rate. It works under the principle of flash pyrolysis and it generates around 70% of oil. Municipal solid waste, especially the polymers and plastics, are pyrolyzed using the fluidized bed reactors. Polymer possess a characteristic feature of low thermal conductivity and high viscosity. Now, high heating efficiency and heat distribution in this fluidized bed reactors always facilitate the cracking of these polymers. However, these reactors suffer from two main problems. One, the charge separation from the reactor is very difficult and better fluidization is achieved with the particles of smaller size. The waste requires pre-treatment before pyrolysis, and after collection the material has to be sorted, dried and crushed into small pieces before loading into the reactor. Now, plastics and paper can be sized up to 5 mm, while the biomass should not be more than 1 centimeter before adding into the pyrolysis unit. The fluidized bed reactors are very difficult to be scaled up and hence normally used in laboratories. Next type is a spouted bed reactor. Now, these reactors are generally operated in a continuous mode. It follows a flash pyrolysis method and it is used again for the polymer pyrolysis. Polymers like polystyrene, polyethylene, polypropylene, polyethylene, tetraphthalate, that is PET bottles, all these things are thermally degraded in a spouted bed reactors. Now, low bed segregation and low attrition makes this reactor more advantageous over the fluidized bed reactor. The polymers generally melt during the addition of plastics into the reactor and they provide a uniform coating around the sand particles. Now, spouted bed reactors are highly versatile and they show excellent heat transfer rate, good gas flow at a very short retention time and faces minimum fluidization problems. Like fluidized bed reactors, spouted bed reactors also operate at a smaller size feedstock. Now, irregular texture, fine particles, sticky solids and those with wide size distribution can be pyrolyzed in a spouted bed reactors. The next type is the rotary kin reactor. They use slow pyrolysis for the thermal degradation of municipal solid waste. It is the only type of reactor that can be used at an industrial level. The waste material is broken down at a temperature of 500 degrees Celsius at a residence time of 1 hour. Like the spouted bed reactors, minimum pre-treatment is also required for this type of reactor. That is, the waste should be sorted, shredded and used as a feedstock. Now, rotary kins are operated both in batch as well as continuous process. They show better heat transfer ability when you compare it with the fixed bed reactors. Again, they are less complicated than your fluidized bed reactors. The residence time is one important factor that will determine the efficiency of pyrolysis in this type of reactor. The energy received by the charge at a given rate is determined by the residence time, which is a function of volumetric flow and rotational speed of the kin. A slow rotational speed of the kin enables better waste mixing, thereby it will result in formation or production of uniform products. Microwave assisted reactors. Now, the waste pyrolysis can also be carried out in this reactors which are subjected to or operated with microwave. As you all know, the wavelength of microwave ranges from 1 mm to 1 meter and the corresponding frequency will be 300 gigahertz to 300 megahertz. In a microwave assisted reactor, the frequency used is between 915 megahertz to 2.45 gigahertz. At this frequency, the waste is pyrolyzed. The microwave assisted reactor are generally supplemented with a lot of advantages like uniform and fast heating, rapid startup and shutdown, good control and high energy efficiency. Now, these reactors does not require any agitation. However, there are some disadvantages associated with the microwave-assisted reactors. Like the organic vapors generated during the process should be removed immediately to avoid cracking of the products. Also, the particles size should be taken care of. Since they involve high operating cost, they are very energy intensive process. Paper, biomass, plastics are generally pyrolyzed in microwave assisted reactors. Plasma reactor, again, plasma is used for destructing the waste. Now, plasma is nothing but an ionized gas with negatively or positively charged ions and generated by subjecting the gas to a strong electric field. Now, plasma is considered as a fourth state matter and it is of two types, the high temperature or fusion plasma and the low temperature or gas discharge plasma. Now, thermal plasma generation can be done by various methods such as radio frequency induction, microwave discharge or alternating and direct current. Plasma burns the waste and it will release the volatile matter and the waste will be cracked into hydrogen and hydrocarbons such as methane and acetylene. Now, the plasma pyrolysis also produces combustible gases like hydrogen, carbon monoxide, methane and a solid residue is also produced. Now, the heating value of the gases will range from 4 to 9 megajoules. Also, the process is very easy to be managed and it works effectively at low power. The last type of reactor is your solar reactor, where you have a transparent Pyrex balloon reactor with a graphite crucible insulated with black foam, and it is located at a focus of 1.5 kilowatt vertical axis solar furnace. It is generally used for wood pyrolysis and it is operated at inert condition by supplying argon gas. The temperature ranges from 600 degrees Celsius to 2000 degrees Celsius. Now, it does not require any additional heating source and they yield around 14% of char at 600 degrees Celsius with a heating rate of 50 degrees Celsius per second. Now, let's look into the advantages of pyrolysis. First, pyrolysis, biodegradable waste and plastics at high temperature. Now, energy is required which can be used as heat or electricity. When compared to mass burning incineration, energy and other value added products are recovered from this advanced thermal treatment process. Now, high temperature involved in pyrolysis will obviously kill the pathogens and harmful organisms. The water volume of the waste will be reduced. Now, the gas produced during the thermal degradation can be used as a fuel, and it will minimize the use of external fuel if a producer gas is used for pyrolysis operation. The char that is produced during pyrolysis can be used as a soil amendment or as an activated carbon. There are also reports which say the biochar can sequester carbon and might increase the fertility of the soil. The oil produced can be combusted directly in boilers and engines. The pyrolysis unit also possesses a potential to degrade the complex pollutants which are present in the solid waste. Now, the recycling of mixed plastic, soiled plastic, plastic laminates, packaging materials which are difficult to be treated by the traditional recycling methods can be pyrolyzed in the pyrolysis unit. It also minimizes the volume of waste and reduces the waste sent to the landfill. The pyrolysis plant are also very flexible and modular in nature. That means the number of units can be added. Moreover, they are very easy to be constructed. Also, the pyrolysis unit produces very low air pollutant emission levels, unlike incineration process. Now, coming to the disadvantages of pyrolysis. Pyrolysis can be used only for residual waste which cannot be recycled or composted. The feedstock of pyrolysis, they always need a pre-treatment or pre-processing. Again, the process is energy intensive and it needs a high capital and operation cost. It requires skilled operators and some air pollution control devices should be installed. The ash that is generated during this thermal degradation will contain very high levels of heavy metals and hence will need safe disposal. To conclude, at the end of this module, I'm sure you would have understood about the advanced thermal treatment technology that is pyrolysis. We have discussed about what is pyrolysis and how it is done, how high temperature or absence of oxygen destructs the waste into 3 different products: the solid, which can be a char, liquid, which is an oil, and a gaseous product, which is combustible. We also discussed about 3 different types of pyrolysis process. One is your fast, slow, and vacuum pyrolysis. We also discussed about the different reactors that are being used for pyrolysis process, starting from your solar reactor, plasma reactor, microwave-assisted reactors, and so on. Then we ended up by discussing about the various advantages and disadvantages of the pyrolysis process. Thank you.